Question number 4, just prove that tangents drawn at the ends of a diameter of a circle are parallel. So when you draw a diameter through the circle, and if you draw tangents at the points where the diameter meets the circle, then those lines are going to be parallel. That's what we have to prove. So we will begin with drawing a circle, then a diameter through it. Then we will draw tangents to this diameter on both the sides, and let's say these diameters meet at point Q and point P at the tangent, and let's say these tangents or the line segments that these tangents are xy and x dash y dash, and P and Q are some points on it. So PQ here is diameter, and there are two things that a diameter implies. First is that it is going to be a straight line. You are not going to have two lines that are bent or that make an angle. It is going to be a straight line, and then it is going to pass through the center. These things are obvious to us, but they will come handy later when we prove it. Now I can apply theorem 10.1 here to say that angle QPX, this angle here, is 90 degrees. Why? Because this is a diameter here, QP, and if you know that theorem 10.1 says that a radius touching the point of contact is perpendicular to it, so the center would be somewhere on this tab on the diameter. So we can say that we have drawn a radius to this point of contact, so that radius is going to be perpendicular to this point at P. This angle is going to be 90, and if this angle is 90, then it follows that angle QPY, because this angle is adjacent to this angle, is also going to be 90, this angle, right? Similarly, we can say it for the other side. Angle PQX dash, that is this angle, is going to be 90. Why? Because if you locate the center on this diameter, and if you draw a line that touches the point Q, then it is going to be perpendicular from theorem 10.1. So this angle is going to be 90, and then angle adjacent to it, that is angle PQY dash, this one is also going to be 90 degrees. Now angle QPX and PQY dash, angle this one QPX and PQY dash, these angles are alternate angles, and these angles are also equal, that they both are 90 degrees. And then angle QPY and OQX dash, these angles QPY and OPX dash, this angle, are also alternate angles, and they are also equal in measure, that's 90 degrees. And when do we have alternate angles equal? When lines are parallel. Otherwise we wouldn't have these angles equal. That means lines xy and x dash y dash are parallel. And now you know that these lines xy and x dash y dash are the lines that are tangent to point P and Q, and point P and Q are the endpoints of the diameter, and these lines are parallel, so the tangents drawn at the endpoints of a diameter are equal. We have proved it. Question 5. Prove that perpendicular at the point of contact to the tangent to a circle passes through the center. That means if you draw a perpendicular from or at the point of contact, then that perpendicular is somewhere going to pass through the center of the circle. Let's see how. Let's draw a circle first. then a tangent to it. Let's say it touches the circle at point P, and let's say this tangent is segment XY. And then now let's draw a small perpendicular, but a perpendicular anyway. Now let's try drawing this perpendicular so that it touches the circle at some point Q, like this here. So PQ here is the perpendicular drawn to the tangent XY at point P. Now, unless I draw this perpendicular by myself, I do not have any way to know whether this passes through the circle center. But I can do it, but I can prove it by some other way, by the negation method. That means I'll assume the opposite or the otherwise of what this statement says. So I'll assume that the line doesn't pass through the center. It is perpendicular, but it won't pass through the center. If the line doesn't pass through the center, that means the center doesn't lie on this line. If it doesn't lie on this line, means it is somewhere else on the circle, not on this line. So suppose it is at point O here, and now let's connect point O and P. This is going to be the radius, and a radius at the point of contact from theorem 10.1 is going to be a perpendicular to that point. So OP is perpendicular to XY. That means angle OPY is 90. But now we have a very weird situation here, that we have two lines making the same angle at a point. We cannot have two lines making the same angle at a point. Two different lines should make two different angles at a point. So we can have only one 90-degree angle here. So either it could be angle OPY or angle QPY. But we are given, or we have drawn angle QPY to be 90. So definitely angle QPY is going to be 90 degrees. And at a point we cannot have two lines making the same angle. That means angle OPY is not going to be 90. If angle OPY is not 90, and if you go back to theorem 10.1, a line from the, if you connect a line or radius, connect a line to the point of contact, then that line is going to be perpendicular to the point of contact, or radius is going to be perpendicular. So if it is not 90, then it is not drawn from the center. And if it's not drawn from the center, then point O is not the center. Or is not the center as we had assumed. So if you want OP to be the center, then it has to make a 90-degree angle at point P. And we know that at point P, or at any point, only one line, no two lines can make the same angle. And we already know that QPY is the perpendicular here, or is the 90-degree angle here. So O, in order to make a 90-degree angle at P, O has to lie somewhere on the line QP. Only then it can make a 90-degree angle. That means O is not going to lie somewhere to make a 90-degree angle at point P. It is not going to lie somewhere else except on the line PQ. That means center, that is O, is always going to be on the line PQ, or line PQ is going to pass through the center O, which is perpendicular, drawn from the point of contact. That means the statement is true, that the perpendicular at the point of contact to a tangent to a circle is always going to pass through the center. Question 6. The length of a tangent from a point A at distance 5 centimeters from the center of the circle is 4 centimeters. Find the radius of the circle. Okay, let's draw the circle first, then locate its center. And this says the length of a tangent from a point A at distance 5 centimeter from the center of the circle. So a little twisted language here. So a point A is located at a distance 5 centimeter from the center. This is going to be 5 centimeters. Point A at distance 5. A tangent, the length of a tangent from this point, that means from point O, is 4 centimeters. And let's say this tangent touches the circle at point X. So this is point of contact. And now let's draw a line from the center to the point of contact, which is going to be radius. And it is going to be perpendicular. That's what we know from theorem 10.1. So angle OXA is going to be 90, and if angle OXA is going to be 90, then the side facing it is going to be, well, if first OXA is a right angle triangle, then the side facing the right angle is going to be hypotenuse, which is the largest side on a right angle triangle. So OA hypotenuse is 5 centimeters, that's given. AX is going to be 4 centimeters, and OX we have to find out. So we can use Pythagoras theorem here. That means the hypotenuse square, or AO square, equals the length of the square of the length of the perpendicular, means AX square, plus the length of the base, or base, is going to be OX square. So let's plug in the values. It's going to be 5 square equals 4 square plus OX square, and now we can solve this. And if we rearrange this, we get OX square equals 9. That means OX is square root of 9. That means OX is 3 centimeters. So the radius here is 3 centimeters. Question 7. Two concentric circles are of radii 5 centimeters and 3 centimeters. Find the length of the chord of the larger circle which touches the smaller circle. So we draw a circle first. Let's locate its center here. Two concentric circles. So draw one more, the larger one, and this is going to be concentric. That means both the circles are going to have the same center. And now let's draw the chord here, a chord to the larger one. And it said it touches the smaller circle. So if this chord is touching the smaller circle, well, if it's touching the smaller circle, does it invariably means that this line is going to be a tangent to the smaller circle? Yes, if it touches the circle, that means it is just touching only one point. If you think that this line can touch 2 points, well, just say this line touches 1 point, then touches one more point on the circle, then there would be line passing through or inside the circle, because it is going through 2 points. Doesn't matter how close these points are or how near they are. So if it says touches the circle, that means it is a tangent, because it can touch at only 1 point, would be touching at only 1 point. So this is indeed a tangent here. Now let's say this center is O, and this chord touches the smaller circle at point X, and let's say this chord, the endpoints of this chord at the circle are A and B. Now let's draw a line from the center of the circle to the point of contact at X, and this line is going to be perpendicular. That's what we know from theorem 10.1. This is 3 centimeters. This is the radius of the smaller circle, which is given here, 3 centimeters. And now let's draw lines from the end point of the chord to the center like this. and these are going to be radius of the larger circle, 5 centimeters. That's given here. So OA is 5 centimeters. Now it is clear here that OXB and OXA, angle OXA and OXB, are 90 degrees. That means triangle OXB is a right angle triangle, thus we can say, and we can use Pythagoras theorem here. And OB is going to be hypotenuse because that's the side facing the right angle here. And let's plug in values now. 5 centimeter square, 5 square equals 3 square plus xb square. And we can now rearrange and calculate xb, that is going to be 4 centimeters. And if you remember in 9th grade, I think that it was the very first theorem in circle chapter, that a perpendicular to a chord inside the circle, a chord will be inside the circle, always bisects it. And OX is perpendicular to the chord AB. That means it is going to bisect AB, and AB is AX and XB. So that means XB and XA are equal. That means AB is twice the length of either AX or XB, and since we know XB, that means twice the length of XB. That means 2 times 4, as XB is 4, it's 8 centimeters.